Hi, in this video, I will show the demo how to start to work in Google Colab for machine learning programs. Initially, we have to open the Google search engine. We can write Colab, then you will get the link welcome to Colaboratory. Then you can click that link. It will open the uh, notebook menu. So here, which is having the welcome to co-laboratory, then here the welcome to co-laboratory, which is provide you the some tutorial for learning. It will help you how to use the Google Colab for machine learning programming. Then you can go to the file menu, new notebook menu option. If you open that, the new notebook is loading. Once the new notebook is loaded, then we can see there is the cell which is the code cell. If you want to insert more code cells, we can use the first tab. So this is the insert code. Okay, we can use this tab to add more number of code cells. Then if we want to delete, we can delete these cells by using the delete option in the right side. Then one more tab is text cell. If you want to add any description to our notebook file in the particular context, we can use this. So for example, this is a machine learning basic file. So like this we can add some description about the thing. So if you want to run it, you can go to the runtime. Here you can run that cell, you can run that shell. And also you look at that, currently I am running this by using the runtime running cell. So now if I want to move this text button up to the cell, I can use the up arrow. So now it goes to the top of the cell. Then now if I want to import any libraries, I can use the import keyword. Then numpy is the numerical Python calculation. Then I am using, instead of numpy, I am using the acronyms np. Once you entered, you can click this play button to run the cell. When you are running, there will be the possible of the dotted circle. It means the cell is executing now. So once this cell is executed, you will get the green color tick mark here. So you look at this green color tick mark, this means the cell is executed now. Then so here I want to upload the CSV file. So to upload the CSV file, we need G drive. So before that, I am saving my file as practice program, right? Practice program. Then I want to locate this in my G drive, Google drive. So that file will be available in the Google drive. So here my file is available in the Colab notebooks. Then now I want to load the data set. To load the data set, I can select the folder. Here my Colab notebook is available in the Google drive, my drive folder. In the my drive folder, Colab notebook is available. In the Colab notebooks, my Colab file is there. Okay, now I want to upload the data set. To upload the data set, I can use file upload. So I click the file upload. Now I want to upload my data set. So I am having data sets, so many data sets. In that I am going to load iris data set. So that iris data set I have selected. Now I am loading. So here it is showing uploading one item in the bottom corner. So here the one upload is completed. Now this file is available in the G drive. Okay, inside the folder my drive, inside that Colab notebooks folder, my data set is available. So here I want to classify the I want to apply the classification ML algorithm. So now I want to connect the G drive with my notebook. So my data set is available inside the G drive. So that Google Drive has to be connected to our notebook practice.ipynb. So for that we are having the library from google.colab import drive. So now I am importing the drive. So for that, so it is executed now. Then now the drive library is imported. Using this drive library, I want to connect the Google Drive with my notebook by using the command drive.mount slash content slash drive slash drive. Okay, so now I am executing it. Now it will ask your Gmail account to connect with the notebook. So connect to Google Drive. So now this notebook is going to connect with the Google Drive. For this, which is asking the Gmail account. Once you are selecting the Gmail account, then it will connect with your notebook. So here I am selecting my Gmail account. Once you are selected, it will ask, is it okay to allow the allow button. Click the allow button. So which is allowing the drive to connect with our current practice notebook. So once it which is connected, then you can check the content which is available in the drive folder. So this is the drive. So in the drive, what are the files available? You can use the list command for that. So inside the drive, I may have some list of files. So I am having the my drive. So now I can access my data set. So data set equal to I am. So here the data set will be the table actually. Okay, the data set will be the table here. So the data set table is actually to be displayed in the to be displayed by using the pandas package. So I have to import pandas package. So I will use the acronym pandas spd. Then now which is executed. So using this pandas package, I can access the data set pd pandas dot read underscore csv, then full path of our file. My file is available inside the content slash drive slash my drive slash colab notebooks. So here I am having my file. My file name is capital IRIS underscore dataset dot csv. So now I am trying to execute this file. So which is executing. The dataset is accessed, connected. Now if I want to look at the dataset content, I can use dataset dot info, dataset information, which is providing you the dataset information columns. How many columns available? We are having 5 columns. One is the sepal length, sepal width, petal width, and the last one is flower. Okay, so here the data type of each column is given here. All data values are floating point values. Last one is categorical data type. Suppose if you want to look at the missing values, we can use dataset dot is null values are there. If null values are there, you will come to know the null values. So false means there is no null values. If there is any null values available, that means missing values available, it will show the true here. Instead of false, you will get the true. If you want to see total number of missing values, you can go with sum. Here there is no missing values. All columns are having zero number of missing values. Now if I want to look at the first 5 rows of my data set, I can go with dataset.head method, which is running the showing the first 5 rows of dataset. Then if we want to look at the last 5 rows of dataset, we can use the dataset.tail. Okay, so now I have connected the dataset and I am checking the features here. Sepal length is first feature, sepal width is second feature, petal length is third feature, petal width is fourth feature. So last one is the output label. Here output label we are having the categorical value. So that we have to convert into the numerical values by using the label encoding. So first we will separate the features. These features will become as a input features. This flower will be the output label in supervised learning. So for that, the input features will be assigned to the variable x. Dataset dot dropping the last column is flower. So now except by dropping the flower column, the remaining all the columns are arranging into the variable x. So this will be the input feature. Now I am executing the input feature. So here we have to mention the axis. So column wise you are copying or row wise copying. I am going to copying column wise. So I am giving the axis 1. So here which is copied. So now if I want to look at that x, you can print the x print the x. Okay, so here which is having 100 rows and 4 columns. You look at here, the flower column is not available because we dropped this. So now this 4 column values only the features for our designing new model. So likewise we can assign the label only the last column as a label, that will be the y. So uh, dataset of, before that we can change that into label encoding. So here we can call from sklearn dot preprocessing import label encoder. Label encoder. Label encoder. Which is giving sklearn spelling mistake. Sklearn. Now yes, the label encoder is imported. Now we can use the label encoder to convert that categorical value, this categorical value flowers, this virginica setosa values into numerical values classes. So that will be acting as a classes. So here if you want to check the values, that we have to transform that. So label encoder has to be applied to the data set. So for that we have to go with, so now I want to assign this data set of flower last column. last column is the flower. This is the output label which is going to be assigned into the variable y. So if you want to check how many how many values are available, there is the three different values available. These are the three values we are going to consider for the class. Then this classes has to be converted into the numerical values. Categorical value has to be converted into numerical value in the machine learning algorithm processing. So for that we will apply the label encoder. Then using that label encoder we are transforming the values which are available in the y into numerical values. So that is assigned to data set of flower. So finally we are assigning the data set of flower into y. Then we are checking y values, y dot unique. So previously we had y dot unique is categorical value. You look at here. Here we had categorical value in the y dot unique. Now the same thing converted into class 0, class 1, class 2. Now we have the input data with us x. Okay, x is the input data and output label is available in y. Output label is available in y. So now we have to check x dot shape comma y dot shape. What is the shape of x and y? So 100 samples with 4 features is the input x. Then 100 samples are the output labels for corresponding this output input samples. This 100 are 100 rows of labels to the corresponding input features. Now this has to be assigned into the, convert into the training data and testing data. So here for converting the training data and testing data we are in need of library sklearn dot model underscore selection import train underscore test underscore split. So this has to be executed. Yes, it is executed. Now I'm going to creating the training data set and testing x comma like that. From the y I am creating y training label, then y testing label. Then these are all creating from train underscore test underscore split of the input features x comma output labels are in y. Then test size I am creating test underscore size. I am creating 20%. 0.2 means 20%. Then I am using a random underscore state equal to some number. So now I am splitting the data set into training data set x train corresponding label, testing data set corresponding labels. Now if you want to check the shape of train x comma testing data or y train, because it should be same number of rows, right? Same number of rows, then only error will not come. So x underscore train 80 samples with 4 features and y underscore train is having 80 labels for corresponding 80 samples. Then if you want to check testing, test underscore x dot shape, sorry, x underscore test, x underscore test dot shape comma y underscore test dot shape. If you want to do it, it will come. So 20 samples with 4 features for testing and 20 rows of labels. Now we will apply the logistic regression. For that we have to import logistic regression from sklearn dot linear underscore model import logistic regression. Logistic regression, which is the one of classification algorithm. So I am executing, which is executed. Now I am going to create the model equal to logistic regression. Right, I created the model. Then I am setting that model dot fit into training. Train x underscore train comma y underscore train. Now, which is completed. Now I am going to predict the, now my model is ready. Now my model is ready. Logistic regression model is ready. So now I can use that model to predict my values. So model dot, so we have to assign this model dot fit equal to again model. Okay, so now we will run. So using this model we can predict the values. So predict the testing data set model dot predict of x underscore test. So which is predicted. Now we have to find out the probability score. Okay, for that we have to import sklearn dot metrics, import score, accuracy score, accuracy sklearn score, no, not this one, accuracy. Otherwise we can use the classification report. So this will give you the accuracy everything. So now print of classification underscore report of test underscore y comma predict. So for this we have to find out the classification. Yeah, 1 minute. Yes, we have to use the probability score. So here we are importing the different metrics: accuracy underscore score, confusion matrix, and mean squared error. Here, which is provide you the training accuracy between the predicted values and training values. The training accuracy is 95%, and here we are predicting the testing values 20 rows. Okay, you look at here, 20 samples are testing data set. The testing data set is predicted. After prediction we are comparing the already existing ground truth value and our calculated values. Here we are getting 95%. The confusion matrix is provide you uh, the samples correctly identified. So 5 samples in the 0th class correctly identified, 7 classes in the first class correctly identified, and 7 samples correctly identified in the 3rd class. But here one sample is misidentified, it is misclassification. That's why we are getting the 95%. So around 19 samples correctly identified, one sample is misclassified. That's why we are getting the 95%. So with this I will conclude this session. Thank you.